Let's look at some examples of this one. Wants us to find the derivative of this function. If you have separate function separated by a negative or positive or a minus or plus sign, remember you can just find those individually. Same thing here with our constant. You can use the same idea that we had with polynomials in these constants of just bringing it with. So we're just really focused on what are these derivatives here. So derivative of this would be, let's bring down our 6. Derivative of cosine is negative sine. And then derivative of cotangent, that's the one we just did a little bit ago, that's negative cosecant squared. And so this answer, if we just write it a little bit nicer, would be negative 6 sine x. Minus a negative, same as plus, so plus cosecant squared x. And that would be the derivative. That would find the slope of this function anywhere on the graph. Let's take a look at this one. This one, we got some division going on. So some of those division rules we're still going to have to apply to these, such as quotient rule. So this one, we're going to need to go quotient rule on it, kind of like we did with that verifying problem before. So our derivative here is going to be low. Our low function is this. D high, derivative of the top is cosine, minus high, sine x again, d low. So the derivative of the bottom, derivative of 1 is 0, derivative of cosine's negative sine. All over our low squared. All right, so now it's just, if you can simplify this, simplify it. Let's distribute that cosine on top, so that'd be cosine x plus cosine squared x. Negative sine times negative sine, it'd be positive sine squared. All over 1 plus cosine x squared. Here, it kind of looks like maybe we're done, but we got our good old friend here again, cosine squared plus cosine squared. We should know that one, that equals 1. So if that equals 1, now we got 1 plus cosine x over 1 plus cosine x squared here. And it looks like we can even reduce further now, because if we got a cosine x on top, 1 plus cosine x on top, and 2 of them on bottom, we should be able to cancel one of those out. So if we cancel that with one of these here, our final answer here would be 1 over 1 plus cosine x. So that would be our simplified derivative on this problem. All right, let's have you try this one. See if you can find the derivative here of x squared times tangent x. Notice these are two functions multiplied to each other, so think about the rule you're going to have to use. So pause it and try it out. All right, let's see what you got. Hopefully you saw to do product rule on this, because you got two functions being multiplied here. So this is one function, this one's the other one. If you need to, go off on the side and find those derivatives, but you want to take one of the functions times the derivative of the second one. So derivative tangent here, what is secant squared, plus, make sure you get the plus in there, because product rule has a plus. Now we're switching around, so now I'm keeping tangent as the function we're keeping the same. That means we got to find derivative of x squared, which would be 2x. Answer for this, there's not really any simplifying we can do. Usually the polynomial terms get written first, so I just wrote those as the start.